20.
Firing chain is armed. Sound suppression water system activated.
10.
Minus 10, 9, 8, 7, 6, 5. Three main engines up and burning. 2, 1. And liftoff of Space Shuttle Atlantis, opening a new chapter in the completion of the International Space Station for the collaboration of nations in space.
Roll program here.
Roger, roll, Atlantis.
Houston is now controlling. Roll maneuver is underway. Atlantis is heading into a heads-down position.
Now let's switch gears and take a look at the theory behind how rocket engines operate. This really is rocket science, but it's not very difficult. First, let's see if we understand the basic physics behind how rocket engines work. Most people make the mistake of thinking rockets work like cars, boats, or airplanes, pushing against something to make them move forward. And that's simply not true. Rockets use a basic rule called Newton's third law that says, for every action, there is an equal and opposite reaction. If you can remember that simple rule, that's really all there is to it. The picture on this slide shows a rocket engine shaped like a cylinder with one end opened, filled with fuel that burns very rapidly to produce energy for flight. The energy is shown as arrows that push out against the walls and nose of the cylinder, and the exhaust is carried out the rear of the rocket with the energy released as it exits the rocket. The rocket isn't moving by pushing against the air or the launcher as it moves forward. It's using that basic rule of action-reaction that tells us that the more energy we can generate, the action, the faster we will move forward, the reaction. The best example I can give without dealing with math is to think of a rocket as a rowboat filled with sailors who are prepared to jump off the stern of the boat when you tell them to. As each one dives off, he pushes against the boat, and the boat moves in the opposite direction. That's action-reaction. If the sailors are really big and there are lots of them, each time one jumps off the stern, the boat moves forward. If you have an endless supply of sailors and can get them to jump faster and faster, the boat gains speed as it travels wherever you decide to point it. And that's how a rocket engine works. Fuel is burned to produce energy and exhaust that is expelled out the rear of the engine, and the rocket moves forward in reaction to that movement. Action-reaction. If you want to know the math formula, it's F equals m times a, or force equals mass times acceleration, and that's Newton's second law. But you really don't need to remember that. Just keep in mind that because action-reaction works anywhere, the higher we fly, the thinner the air gets, so the force of thrust, which is mass times acceleration, grows as we go higher, giving us the advantage of more efficient operation as we get closer to a true vacuum of space. The only limit is the amount of fuel we can carry and how fast we convert it into energy. Whether it's liquid or solid fuel, it's all the same to Newton's third law. Trust me, it works.